In this slide, we'll analyze a positive consumption externality. This is a case where the act of consuming a good provides a benefit to the consumer themselves, but also has a social benefit as well. An example of this is a private property owner who decides to consume landscaping in front of their house. This, of course, improves the visual appearance of their house, which is a benefit to the homeowner. It also improves the property value itself, which is a benefit to the homeowner themselves. But it does another thing, which is it improves the property values of adjacent houses and maybe other houses in the neighborhood or on the block. This is a benefit that doesn't accrue to the consumer themselves, but accrues to society as a whole. So since this is a consumption externality, we move the demand curve. The demand curve, of course, measures the private marginal benefit. Let's add the social benefit of consumption in this case by clicking on this graph. Notice that this social benefit is in addition to the private benefit, so we move the demand curve up and get the social marginal benefit curve. Now we can analyze the market equilibrium which occurs at Q1 with a socially efficient equilibrium which would occur at Q2 if the true benefits were accounted for in the private market. Note that the private market provides an amount of landscaping equal to Q1, and using our example, the socially efficient amount of landscaping is actually Q2, because the benefits accrue not only to the consumer but also to the community as a whole. Due to the fact that only Q1 gets produced, but Q2 is socially efficient, we have what we call the deadweight loss. The deadweight loss, again, is the difference between how much benefit we could have gained from consuming the socially optimal amount of landscaping versus how much benefit we did gain by consuming the private market amount of landscaping. The difference between the two gives us, again, the deadweight loss, which can be measured as this triangle here. Note, in passing, that this triangle is identical to the triangle that would occur here if we extended this line of Q1 up. That might be slightly more intuitive, but either way, it becomes the same amount.